Hi everyone, this is just a quick example on Venn diagrams and calculating the number of outcomes in events and also calculating the probability of an event using some of our operations for events. Right, it says here that of 100 students, 65 take mathematics and 31 take chemistry. Then question A, if 20 students are in both classes, how many students are in neither class? Question B, how many are in either class? And question C, what is the probability that a randomly chosen student from this group is taking only the chemistry class? Right, so let's start with the information that's given. First of all, I'm going to use M to denote the mathematics group and C to denote the chemistry group. Then I'm going to have a Venn diagram, which of course will be a rectangle indicating the sample space. Then I'll have a shape inside representing the mathematics students and a shape for C which represents the chemistry students. Now if I look at what each of these sections are, then this part on the left will be only mathematics students. So this part here will be only mathematics. So the notation used here is mathematics and not chemistry, because none of the students in here is involved in chemistry. If we look at the middle part over here, then this is the part which has the mathematics students and the chemistry students. And then of course this part on the right hand side, this will be the students that do not do mathematics and they do chemistry. Now we have 100 students in total, and of course there are students outside of this event, right? So students outside of the mathematics and the chemistry groups, they will probably be doing something else. So the students that are outside of here, they are the students who are not in mathematics and also not in chemistry. So the primes denote the complement of the events, so not mathematics and not chemistry. Now question A, it says if 20 students are in both classes, how many students are in neither class? Okay, so in other words, they're telling us how many students are in both. So this is the group that's in both. And then they're asking how many are in neither class. So this group here that's sitting outside of the pink and the green events, they are the ones that are in neither class. So they're telling us that M intersection C contains 20 students, and they're asking us how many are sitting outside. So if you write in that information, then we have 20 in the middle, but we also know how many are taking mathematics. That's 65. So that means the green event here contains 65 students. So if 20 is in here in the middle, then it means 20 subtracted from 65 means that 45 students are sitting over there. We also know that 31 students are taking chemistry, in other words sitting in the pink event. So if there's 31 in the pink event and 20 in the middle, that means 20 subtracted from 31, so that will be 11 that's sitting over there. Now in total we have 100 students. So if there's 100 students, but 45 are in there, 20 are in there, and 11 are in there, then that means the total that is sitting outside of these two events will simply be 100 minus these three values. So it's 100 minus 45, that's 55, minus 20, that's 35, minus 11, that is 24. So in other words, we have 24 students sitting in neither class. Now there is another way of doing this. Okay, the method I just used was the Venn diagram. We can also just do it using some straightforward calculations. We are interested in the number of students. Okay, this hash sign will be the number of students in this event that's not in mathematics and also not in chemistry. This is equal to the complement of the union, and the complement of the union will be 100 minus the union. Now we can calculate the union, M union C, that is simply everything inside of M and C. So M union C will be everything in mathematics, which is 65, plus everybody in chemistry, which is 31, minus everybody in the intersection, in other words minus 20, and we're subtracting 20 because when we take 65 plus 31, we are adding this intersection twice because 20 is counted as part of the 65, it's also counted as part of the 31. So we subtract 120, okay, one group of 20, so that will be 96 minus 20, which is 76. So here we have our union, so that means 100 minus 76 will be 24. But in this case, it's just easier using the Venn diagram. Right, now question B. How many are in either class? In other words, how many is either in mathematics or in chemistry only? Right, so those in mathematics only will be M and C complement. Those in chemistry only will be M complement and C. So these are not in chemistry but they're in mathematics, and these are not in mathematics but they're in chemistry. So they are in either class. If you're sitting in the middle here, it means that you are in both classes, but we don't want that. We want either class. So we just see how many are in these two and we simply add it together. So easy enough, we've already calculated it. It's 45 in the one, 11 in the other, so it's 56 in total. Now again, there's another way of doing this. We can start off by looking at the number of students that do only mathematics. That number of students doing mathematics, right, that's in the green, they will be made up of those mathematics and not chemistry, and those mathematics and chemistry. So that's these two that's being added together. Now I know what the mathematics is, that's 65. I know what mathematics and chemistry is, that's 20. So now substituting 65 and 20, I can solve for mathematics and not chemistry, and that gives me 45. Right, secondly, for the chemistry, I use the same approach. Chemistry is made up of those that do mathematics and chemistry, and those that don't do mathematics and also do chemistry. So those two groups over there. I know how many are doing chemistry, that's 31. I know how many are doing chemistry and mathematics, that's 20. Okay, so I know the total over here for chemistry is 31. I know the total for the intersection is 20. So that means not mathematics and chemistry, which is this part on the right hand side. Okay, I know that that will be equal to 11. Right, so now that I have the 45 and 11, I simply add it together to get 56. Now please note that these calculations in the red are meant for when you don't have a Venn diagram. Right, but again, also in this question B, it's much easier if we can construct a Venn diagram because everything is readable from there. Right, now lastly, what is the probability now that a randomly chosen student from this group is taking only the chemistry class? Okay, so the probability of only chemistry, how do we indicate that using our events? That will be not mathematics and chemistry. So only chemistry means this section on the right hand side. This is only the chemistry group. Right, now as we can see, we've already calculated this, and that is just 11. Now the way in which we'll calculate the probability is to simply introduce the sample size of 100. So we have our probability of not mathematics and chemistry, okay, which needs to be calculated. We know what the total is for chemistry. Okay, we know that the total is for chemistry, that's 31. We know what the total is for mathematics and chemistry, that's 20. So that means I'll take the probability for chemistry, which will be 31 over 100, and I'll subtract the probability of the intersection, which is 20 over 100. Okay, so to calculate the probability, I simply divide by the sample size. Right, so that means I end up with 11 over 100, which is what we already have over there. And another way of writing it in decimal form, 0.11. Right, so what we also could have done is, seeing as we already have our Venn diagram, we could have just gone here and taken this 11 over here and simply divide that by 100 to get the probability of 11.